Okay, I just launched NanoVNA-Saver version 0.5.5. Okay, first thing I should do is I'll connect my device. Okay, it grabs whatever my device is set at. I'll just do a sweep to be sure. Okay, I'm going to load my calibration, which I've created a while back. And I'll use this one, I guess. Okay, so it's calibrated. Display setup. I turned off I have the VSWR, the Smith charge, my TDR, which is going to give me my transmission length, and quality factor, which I have to look into still. Custom charge if I want. Some of these settings are don't get saved all, so you have to double check. And I also notice when you open a window, let's say this one here, I want to change my RG8, which is 58 AU. If I don't close the window, it falls in behind. I can't bring it up unless I minimize this one. So it's a good habit is to close it off the bat for now. Obviously, it's probably just a software update required. Okay, I'll do another sweep. I got this set up, I believe. Oh, let me do an average sweep. Basically, it's going to do it 3 times. I have an antenna hooked up. It's a VHF UHF. It's just sitting on the floor on a simple metal pan. And I have it set for a bandwidth of 144 megahertz to 148. And I guess this one here, I'm going to put in the center. And this one I'm going to put at the end. And there you go. So, number 1 marker, 144 megahertz. Impedance at that end is 56, which is okay. And my VSR is 1.346. Go to the middle one. The wavelength, which is correct for 2 meters. Impedance is a little bit better, 52. So that actually is very good. And the VSR is 1.2. Anything below 1.5 is great. And if I want to take a look at this point, 148. Again, almost this under 52. Impedance is 1.2 under. So for 2 meters, my standing wave ratio is perfect. Now, I'm going to enter the 70 centimeter band UHF. And I'm going to do a sweep. Okay, there's my chart. Actually, on UHF, my antenna is even better. At 350, 48 ohms, standing wave ratio 1.07. Likewise with this one, in the middle of the band, 48 ohms, close enough. 1.07, it's almost flat. And likewise over here, at the far end of the band. And I have 48, 1.0. So it tells me my VHF, UHF mag mount sitting on the floor, all within specs. So much easier and quicker using the NanoVNA-Saver. My NanoVNA, the H4, I basically have everything turned on. The only thing that might not be turned on is my transmission, which I have to turn on manually when I want to do the estimate cable length, or the TDR, which is right here. So the figures are of no value because it's not able to tell. Now, if I go to my unit, go for display. Oh, you know something? It does say the transformer's on. Okay. So, why is it saying 0? Well, it's because there is one more requirement. Now, if I was to use the unit itself, I would have to do some calculation and a bit of setting. This app does that automatically. The NanoVNA-Saver. You use a lower frequency to measure a longer length and a higher frequency to measure a shorter length. Okay. Right now I'm using a very short length, 70 centimeters. I'm not going to get an accurate reading what the length of my transmission line. Let me just switch one here, 100 megs. See how that looks. And there you go. 4.65, which is almost 15 feet, I believe. I can get a little bit more accurate by playing around with the frequency. But if I just want a quick reference to how long my cable is, let me switch. I have a 100-foot cable. Let's see how accurate it is in reading that one. I just unplugged my antenna. Okay. Okay, I'm going to take this barrel off and just screwing on the, oops, I'm hitting the keyboard here. Okay. Oops. This is a heavy cable, so I want some move everything, so I'll just put it down a little bit. Okay, let me go to calibration, I believe. No. Time domain, that's where I need to change my cabling, which is 2013. Okay, that's done. Now I'm going to put this down. Let's try 9. The longer the cable, okay, I think I said 50 foot, 100 foot. It's actually 50 foot. So there you go. 15.5. That's pretty close. Again, if you want to get a little bit more accurate, then you have to do a bit of math, pick the right frequency so that you can get it closer, as the instruction says. A lower frequency to measure a longer length, and a higher frequency to measure a shorter length. This one, we're talking about maybe differences of a few inches. This is a brand new cable. I should measure it out. It was sold to me as a 50-footer. So the experiment I've done in the past seemed to indicate, I believe around 15.24 is what 50-foot would be. So, and I managed to get that just by changing, I think the start around 500 kilohertz. And I believe the stop was like 9 megahertz. Let me try that here right now. Let's see, 500. Oops. Kilohertz. And to 9 megahertz. Let's do a sweep. There you go. More accurate. It works. I said 15.24, 15.274. There. So much quicker, less fiddling. I don't bother saving any settings on my NanoVNA-H4 because most of my adjustments will be at the computer. So is it worth having this NanoVNA-Saver installed? For me, yes, for sure. And I think if you want to not fool around with using a touch screen with a little pencil and that small little unit, there's several times where I made changes and I accidentally changed something else, and then you have to go find where you changed it. So this is certainly is much more convenient. I'm glad I went to the trouble of installing this. It's worth it. Now I can do a whole bunch of other stuff which I wanted to do in the past because it didn't have the missing part installed on my Mac OS. Apple does not install this stuff by default, but it is part of their programming system, Xcode, stuff like that. I would recommend it. Well, hopefully this helps. Now you know how to check your standing wave ratio, and you also know how to check the length of your coax. And if you know, for example, you have a coax at perhaps 200 feet and you keep getting a reading of 150 feet, then you know somewhere in that area there's a problem with that coax. Could be bent, nicked, or even cut. So that's where you would go to look for it and physically check if there's some sort of physical damage. The other thing left for me to do is to check the impedance, or not the impedance, but the loss, cable loss. That's another area that's essential, especially you have older cable, been outside for a while. It may have got damaged through UV, moisture, things of that sort, and you're wondering why you're not getting out as far, thinking it's just conditions, when in reality you got a bad cable. So that'll be my next little project, is to use this 50-foot, find out if it meets the manufacturer's specs to its loss. Have a nice day. High SWR and bad coax cable can cause interference to your neighbors, and the higher the frequency you operate, the higher the loss even on a new cable. That's why you need to choose the right cable if you want to maximize your operation.